Hello everyone, I am Angela and I'll be here as a tech support during the tutorial. I want to introduce you to our tutor, Milica Scepanovic. She is the head of consulting at Management Center Belgrade and she will hold the storytelling through data tutorial. Enjoy!
Hello everyone, I hope you can hear me well. Thank you for the introduction. As it was said, I work for Management Center Belgrade. And I work as a head of consulting. What I do is mostly projects related to data reporting, finance controlling, and similar topics. So we're going to have one workshop that's going to be a bit different to other workshops that you had today, because we're going to be focused on visualizations mainly and storytelling with data. So this workshop won't be as technical as other workshops today and tomorrow, but I hope that it will be very interesting to everyone who is here. So let's start. I will share my screen. All right, I will start with one important question that we always need to start with when it comes to any topic or any area that we're talking about. And that is the first question: what skills do we need to make a career in data, whether it's data analysis, data science, data engineering, etc. We need to know the skill set that's required. So if you ask anyone what skill set is required to make a career in data, first thing that people will tell you is probably knowledge of how to use different tools such as Excel, Power BI, Python, R, etc. So we need to have technical knowledge, or we need to have some sort of technical tool set. However, just knowledge of technical tools is not enough for a job in data science or data analysis. So we need to have something that links with statistics and mathematics, and therefore we need skills in these areas such as probability distributions, regressions, machine learning, etc. So when you combine these two, this is mostly what everyone who is studying to become a data scientist is learning all the time during their training. But once they start working and applying the skills that they have learned, they need to combine these skills with some domain knowledge, which is the third circle that we're talking about here. And domain knowledge is usually business knowledge. This is the knowledge of the company that you are working for, or this is the knowledge of the area of science that you are working on. So, for instance, if I'm a data scientist in one company and I want to apply my knowledge in another company, which is in different industry, this can be a challenge because I need to learn the business first before I can give my full contribution to the other company. So usually people mention these three pillars when it comes to skill set that you need in order to make a career in data. However, it's important that we have a fourth circle as well. And I'm going to mention the fourth circle here. And this is going to be our main topic. So it's soft skills, or skills in communication and visualization. So what does this mean, soft skills in communication, visualization? Usually when you talk to someone who has really good technical skills, such as knowledge of coding and math and stats knowledge, these people are usually focused on, I would say, back end of the models. They're developing models, they are learning from data a lot, and they are building some sort of data product. But when you talk about people who work in companies, people who work, I would say, in traditional companies, not product-based companies, they usually need to have a tool how to communicate their findings to other people within their organization. So what they need is a way how to transfer this complex knowledge to people who are not as technically skilled as they are. So basically, the main problem that we have here is how to present something which is complex in an easy way. And this is going to be the topic of our discussion today and the topic of this presentation. So first of all, you might ask me a question, why does this matter at all? So what is the whole point of having these communication visualization skills? And I will answer this question with one study that was done by KPMG in Germany a couple of years ago. And basically, the study was focused on the way we perceive different visualizations that we see. So I will explain the study first. The study was focused on showing the participants different graphs, different visuals, and the participants needed to answer the questions based on the visuals that they saw. So once they see the visual, they are asked a question, for instance, which market has the highest market share, etc. So they need to reply to this question. They need to reply fast, and of course, they need to reply accurately. So basically, the main goal was to determine which visualizations are the ones that provide the highest responses, as well as the most accurate responses. So let's repeat this experiment, and I will show you quickly one visualization from this study, and you need to answer the question. Answer this question in your head or write it down, and you will see if you were right. So the question that I'm going to ask you is, you will see 6 different graphs, and you need to reply, where was the sales highest in June? So you will have 6 graphs. You need to reply which product group had the highest sales in June. So let's have a look. And it's gone now. So what was the purpose of this one? You might have some thinking of which one is the answer. But basically, what is the whole study based on? They were recording the eye movement of the participants in this study. And if you look at the eye movement of the participants who were shown this picture, it looks something like this. So this was in German, so that's why the words are different here. But basically what you can see is these bubbles. And the bigger the bubble, the more time your eyes spent on the specific part of the visualization. So what was the main problem in this visualization? You might have noticed that the main problem was the scale. So not all visualizations started from 0. Some of them started from higher numbers, such as this one. This one started from 50. And the other issue was that the whole y-axis was not the same. This one ends at 300, this one ends at 550, 150, etc. So it's really tough for us to determine which one has the highest sales in June. And when you look at this, this is not a complex issue. This should be very easy to answer. So this is really easy question that I asked you, but if you voted now, you would probably all have different answers which were not correct, because this visualization is bad. This visualization is lying to you because it's showing you wrong scaling. So if I show you this visualization now, but with correct scaling, let's give it a try. Look at this now. Isn't it obvious now? So when we correct the scaling, first of all, we don't need y-axis anymore because we know that this is all on the same scale. As well as that, we have added the labels on top of each bar, and we can see easily that Technics has the highest sale in June. If we now record the eye movement with this one, what you get is something like this. So what can we determine from this? First of all, much less eye movement. So that means that the user of this visual makes it easier to read it. And that's one thing. The other thing is accuracy. People will make correct conclusions based on the other one compared to the first one. Because when you look at the first one, the rate of people who gave wrong answers was really, really high. So you might ask yourself, why is it that anyone in this world would make this sort of mistake? Why do we make mistakes when we create visualizations? And are we doing that on purpose? What is the reason behind all of that at all? So let's ask ourselves this question: why do we make bad visualizations? I'm not saying that all visualizations are bad, but majority of them have some space for improvement. So why do we make bad visualizations? I will give you one example of a bad visualization. Let's look at this presentation delivered by Bill Gates a couple of years ago. And if you look at this presentation, you might not be familiar with the technology that he's presenting here. So he's presenting Microsoft Live platform, and I'm not sure if anyone is using this platform. The reason why is because this idea was not accepted by public in general. Why is that? Because this presentation just wasn't as good as it should have been. So let's try to understand what he wanted to deliver as a message from this presentation. What we can see here at the bottom, we have different devices. Some of them are PCs, some of them are mobile phones, etc. Some of them are machines such as a train and stuff. And on top of these devices, we have different softwares which are operating on these devices, which then connect to some server, which is somewhere in the cloud. And we can see that on top of everything, they are all connected with each other. So this is a concept that we are familiar with today, right? And we call this concept cloud. The reason why we call it cloud, because Apple had a solution called iCloud that was presented in a much better way and in a much easier way to understand by those who were looking at the presentation and those who were then the next ones to accept the solution. So what is the key message here? We shouldn't make things too complicated. When you look at this slide has too much information that is not relevant to deliver the message. I mean, it is relevant information, but it's just too much at this stage. Also, there's too much color, there's too much shades, there's too much those clouds and too many details on the clouds. So this is really hard for us to perceive, and that's why we just ignore visualizations that we see which look like this. So we have too many options. When you look at, for instance, Microsoft Office, Excel, PowerPoint and stuff, you have so many options for shading, 3D effects, etc. And just because you have these options doesn't mean that you have to use all of them at the same time. If you look at Excel, for instance, I will start with Excel. So if you want to add a simple chart, if you want to add a column chart or bar chart, you have these options. So you have 1, 2, 3, 4, 5, 6, 7 different options for a column chart. Do you need all of these? Do you need 7 different combinations, or maybe you need 1 or 2? Also, if you look here on the side, we have even more types of visualizations. Do we really use all of these, or should we use all of these? That's a really good question that we need to ask ourselves. This is an example from Excel. So as you can see, Excel gives many options for data visualizations. And usually when you need to visualize something, you just pick one of these, whichever looks the prettiest to you, and then you just proceed with that one. If you look at other tools, such as Power BI that we can see over here, the case is the same. So this is an example from Power BI, a dashboard. And on the right-hand side, you can see different sorts of visualizations that you can create. And of course, you can change the formatting of them, and then you end up with something like this one that we see here on the screen. So this is typically what people do with visualizations. They want to make them interesting by playing with colors, playing with shapes and stuff, playing with different sorts of visualizations. And this is really bad for the other person who's reading the report, because this is really hard for the analysis. I've mentioned Excel, I've mentioned Power BI. I'm going to proceed to Python. And when it comes to Python, unfortunately, we have even worse situation, because we have so many libraries in Python. And I've taken Matplotlib as one of the examples here, where I took a screenshot of the documentation. And these are just visualizations which are available for statistical distributions. You have many more in Matplotlib. And of course, you know that Matplotlib is just one of libraries which you have for data visualizations. So you have tons of options, and it's really hard to know which one should I use. Should I use a box plot or violent plot? When should I use one or another? Or should I use something else? Maybe I should use a histogram for this one. It's really hard to know which one to use in which situation. So this is one of the main issues. Tools simply provide way too many options, and sometimes we don't need more options. Sometimes we just need a way to apply all these options, and we need someone to tell us how to do things, when to pick a histogram, when to pick a bar chart, when to pick a column chart, when to pick a pie chart. Should we use pie chart at all? So these are all questions that we need to have an answer to. So as I have mentioned, we have so many options in different tools. And because of all these options, each one of us, when we create our visualizations, we pick one option and then proceed with that option. So we end up with various visualizations. What did we end up with? Usually, our visualizations look similar to this one that we can see over here. So there's a lot of color. There's a lot of elements on each one of the charts. And sometimes it's really hard to understand what is the whole point, what's happening here. If you look at this one on the bottom, you can see that we have here 3 scenarios for the first variables, which is in columns. And on top of that, we have 2 scenarios for the line chart. So sometimes it's really hard to follow and to see what are the relationships between these figures. So we need something better than this. Out of all these options, it was really hard to determine which ones were the most relevant ones. Sometimes when we have so many options and don't even know where to start, we end up with visualizations like this one. So this is an actual example of a report from a company here in Serbia. So there's no visualization. There's one here, and it's grayscale. But this table is horrible. No one reads this sort of reports because this is just too much information. So we need some sort of solution for issues such as this one. And let's see what is the solution, or what do we propose as a solution here. What we need to focus on is simplicity. And I will highlight simplicity here as the first main thing that you need to remember when it comes to visualization in general, not just data visualization. If you look at this presentation given by Steve Jobs, this presentation is so simple. He's showing you a product with just one picture. If you compare this one to Microsoft Live platform that we saw a couple of slides ago, this one has much less pictures, much less colors, much less shapes. It's just one photo, but it gives us so many information, a lot of information here. So what can we take from this one? We can see that one picture shows a lot of things that Steve Jobs wants to deliver as a message here. To begin with, he's showing us that this device that we see here, that we used to use around 10 years ago, is really small, and it can be transferred on your t-shirt. You can wear it anywhere you want. You can connect it to your headphones, and you can enjoy music wherever you are. All of that information is contained within this one photo. If we look at some other presentations from Steve Jobs, you can see, for instance, in this one, you can see also it's simple, just one photo with one piece of information that is highlighted, which is the most relevant, most important information. If you look at another slide, also it's always very, very simple, and it always delivers the right message that we want to show. So how can we apply all this knowledge to the data visualization, and how can we tell stories with data based on all this that we have seen here? So let's start with one bad example, and I will show you one bad example here, which shows sales figures by customers for one company. And this is just a table. This is no visualization yet. How can we make this some data which has insights? How can we make a story out of this data? If you present this data to anyone, people will need to analyze this table first, and they will need to understand, all right, so what happened with customer D? Let's look at this figure. Let's compare it to this figure. We see the trend here. So this one is growing. Let's look at the share. Is the share relevant here? Is it not relevant? Does the trend in share matter, or it doesn't matter? So we need to think a lot when we are presented with something like this. So this is obviously a bad example because it doesn't tell any story. We need to make it tell us a story. And what I'm going to show you now is an example of this table transformed into something that tells a story. So let's move to this one. So what is the main difference between the previous one and this one? First of all, we have a message which is on top. So this one is in Serbian, so I will not comment on what the message is showing us. For those who speak Serbian, you can understand. But the main difference is we do have a message here. So we want to show something with the table that was presented here. So once we picked the message, then another step was to pick the correct visualization. So we were talking about sales figures by different customers, and we have picked a bar chart here. And by this bar chart, we can see how big each customer is. So if you look at the previous one, it was really hard to compare the figures here. It was really hard to tell that this one is almost 5 times as big as this one, whereas here it's much easier to see that visually. Additionally, we can see that top 10 are here and others are here. So we can see that top 10 constitutes roughly 50% of all customers. Another thing that we can see over here is we can see the difference compared to last year, which is visualized correctly. So if a customer is growing, then it's shown with green bar and it's shown with a sign plus, whereas if it's less than last year, it's red with a sign minus. As well as that, we have another bar chart which is showing percentage variances, and here we can see also if it's good, it's plus, if it's bad, it's minus, and the green and red. And another thing is not to confuse percentages with exact figures. We have picked a different sort of bars for this one. So if you look at it, these bars are much thinner and they have pins on the end. So this makes them easier to be distinguished from the absolute figures. What is another thing that we have over here? So one other thing that we have is highlighting. So in the key message, we mentioned this figure. So we want to highlight this figure over here as well, and we want to highlight this figure over here as well. So these are the main figures that we talked about and want them to be somehow distinguished here. All right, so this was a first example. Let's have a look at another examples. So I will show you one example which is really hard to read. And of course, we're not going to read all of this. So this is an example from one company where this sort of data was sent to their management daily. And this is data from their production facilities. And it's really a lot of data. Really, it's good data, but it's not presented in the right way. There's so much text, there's so many visualizations, there's too much data. And the outcome was that no one was looking at this data. This is valuable data. This is data that you need to run the business, but no one was using it because it was presented in a bad way. So how can we improve this one? Let's look at the solution. So first of all, we need to have the main message on top. And in this case, this message was related to the production per shift. So how much was shipped per one shift and the reason why it's not according to plan. So we have the message here on top, and below that we have the main visualization which supports the message. So I'm showing you here the same things as on the previous slide, but it's presented in absolutely different way. So what we can see here, we see different shifts day by day. So we have 2 shifts per day here on axis, and what we can see here is the value of the goods that were shipped. We can see the average line, this is this black line, and we can see the target, which is the blue line, and we can see the difference between these two. So we can see here the difference is red, so it's bad, it's less than planned. So what is the reason why it's less than planned? How can we improve? So if we ask this question, how can we improve? We need to look at 2 main aspects. First aspect is quantity. Another aspect is money. So we have like, this is the total amount of goods shipped. So did we ship less goods or did we ship goods which had less value? So what we can see here, obviously, the biggest difference was here in the amount of goods shipped. So we shipped less value than less amounts than we were supposed to. So that's the main reason. And based on this, production manager can make actions, and they can change something tomorrow in another shift, and they can perhaps hire more people to work on a certain part of production in order to fulfill this goal that they had here. So basically, visualization does matter. And when you have bad visualizations, it's really hard for people to make decisions based on your bad visualizations. So let's see what methodology we used here, or how can you apply things similar to the things that I applied over here. And the methodology that we use here is called success rules. It's a methodology developed by International Business Communication Standards, or IBCS. And I'm going to introduce you to this methodology. So what does it mean, success rules? Success is acronym, and we're going to explain each one of the letters here. So the first letter is S, say it, and this means that you need to deliver the message. Whenever you create some sort of visualization, or when you create a report, dashboard, you need to keep in mind that this needs to deliver a message. If you're creating a report, you should always have a message on top. So message is something that needs to be in each one of the reports. If you are creating a dashboard, of course, data is changing through time. So you can't always have the same message with data, but you need to have the message in mind when you are picking what to put into the visualization and what to exclude. After that, we need to unify, which means we need to standardize notations, colors, etc. So if you look at the examples that I've shown you before, I've shown you that we used red for bad things, green for good things. We used black for everything else. We used blue for highlighting, etc. So you need to standardize things in your dashboards. Then another rule is condense, which means do not waste space, basically. If you have a visualization, a single visualization on a page, that's not good. You need to use each pixel that you have on your screen. So if the whole visualization can fit into just this one segment of your screen, then you should just make it smaller and put it into that segment and use the other part of your screen for more valuable information. Then we have another rule, which is called check, ensure the quality of information, which means that you need to ensure that you're not lying the other side unintentionally. What does this mean? So if you look at the example with scaling that we had before, we didn't lie about any figures. We just showed them in a bad way. So we presented them to deliver some different sort of message compared to the true message that we have. So check means always ensure that you're not visually lying the other side. Then we have a group of rules called express the message visually. So there are some rules which visualizations you need to use in what situation. So I will show you some of the rules here in Express. So this basically relates to the choice of graphs of visualizations that you have in your dashboards. Simplify, make it as simple as possible. So you should get rid of anything that doesn't support your message. So if you have, such as in the Microsoft presentation that we've seen before, if you have too many colors, if you have too many bubbles, if you have too many objects on your dashboard, just get rid of all of that. Just keep the things that are necessary for your dashboard or your report to deliver the main message. And finally, we have a rule called structure, organize the report, which relates to the way we represent different bits of information in our report. So if we have a couple of visualizations, couple of graphs on the same dashboard, we need to see how to sort them, how to present them in the right way. If we look back at one of my previous slides, you could see that we had 3 graphs where we had one which was equal to another one multiplied by the third one. So we have organized them visually in a way that the other person can understand what we wanted to say with these graphs and how the formula is calculated. All right, so this methodology that I've shown you here is based on international business communication standards, the whole methodology is available online as well as in books. This is a book that we have issued, as well as another book which IBCS has issued themselves. So if you're interested in this sort of methodology, you can read the books and you can get all of this from these books as well, or you can visit the websites. All right, so let's dig deeper into the rules. And I will present the top 5 rules which you can start applying from now on in all of your visualizations. So first rule that we're going to use is show time comparisons on horizontal axis and structural comparisons on the vertical axis. So what does this mean in practice? So if we have time comparison, it should look like this. So we should use x-axis for time comparison, whereas if you have structural comparisons, such as different countries, for instance, we should use y-axis for these comparisons. This might seem logical to you, but people quite often make a mistake between these two, and they put countries here, or they put time data over here, and it's not that good. So you should get used to showing structural comparisons like this, top to bottom, and time comparisons left to right. Another rule that you're going to use over here says unify the titles of graphs and tables. So I have mentioned the message, and message should always be the first thing on your report if you're creating a static report. But another thing that you need to have is the title. What is the title? So it's this bit over here, which shows which data we're looking at. So if you look at this one, for instance, this is Alpha Limited company. We are looking at net sales in millions of euros for 2023. So in here, we know what sort of data we are dealing with. So we know if it's net sales, if it's gross sales, if it's net profits and stuff. And we know that this is alpha. So we know it's not alpha and beta combined or just one market of alpha. So we need to be sure which data we're looking at. And the best way to standardize that is always to have the organization first, or in case you have even more details, for instance, alpha market X, then you can say alpha market X or customer X, etc. And after that, you have the measurement that you're showing, which is net sales here, and also the units in millions of euros. Usually, sometimes people just forget the units. So we're not sure if you're talking about millions, thousands, or whatever. And after everything, you should show what time span this relates to. So this is 2023 in this case. All right, let's look at the next rule. So the rule number 3 states distinguish scenarios by color. So usually you have various scenarios when you're presenting data. And the most used one is the scenario called actual. What does actual mean? So this is figures that you have measured. basically, and this is the figures that you either got from your system or you got from some device, etc. So this is the actual figures that you're working with. When you have the actual figures, what you want to make based on these actual figures is forecasts for the future. So if you are forecasting, for instance, time series, or if you want to make predictions with ML models and stuff, you want to distinguish these predictions from the actual data that you have. So if we show actual with black, we want to show forecasts with some other color. And what we suggest here is to use hash. So to use these like small lines, and you can see visually that it looks different to black. So it's a good practice to distinguish them. Another thing which you can have in your visualization is also a plan or budget. And this one should be different from both actual and forecast figures because it's something that you have planned in advance. So we suggest that you show plan with outline or with white color, just with the outline. Sometimes you also have different scenarios such as previous year. So in case you are using previous year figures on the same visualization as the actual year figures or previous period figures, you can use the shading. So if you're using black color for the actuals, you can use gray color for the last year figures. I'm going to show you how to apply all of these rules soon. So you shouldn't worry if this is too much information at this point now. All right, so let's see the fourth rule. Variances are colored green for good and red for bad, and relative variances are shown with pins. So let's see how to apply this. This is similar to something that we have seen in one of my examples before. So when we have variances, they are green if they're good, red if they're bad, and if there are percentage variances, so this is 8%, 1.4 divided by 18.48. So if it's percentage variance, then simply it's just smaller line, thinner line with a pin on top, and also we have plus and minus here, green and red as well. And another fifth rule out of these top 5 rules says for all other highlighting, we use a different color, for instance, blue color. So if you look at this one and you want to highlight whichever figure, for instance, you want to highlight July for any reason, then you can just highlight it with blue color or any other color that you have picked for neutral highlighting. All right, so we have seen top 5 rules, and we need to see how to apply them to make our visualizations better. So what I'm going to show you first is I'm going to show you one visualization that was done in Power BI, and then a message was written on top of it. And we want to improve this visualization by applying these 5 rules. So let's start. First of all, we can see the visualization over here. And on top of that, we can see the main message of this visualization. Women's apparel is 4% below plan in the mix. So we first thing that we should think about here is what is the main message. We want to deliver the message about women's apparel. And for those who don't speak Serbian, women's apparel is the purple color here. So this is the biggest bar that we can see over here, this odevni predmeti. So how can we highlight this message? The first problem that we see over here is we have a message which states 4% below plan, but we don't see 4% anywhere. So we cannot even see the figures that the message is talking about. This is a problem, obviously. So we need to introduce these 4% into our visualization somehow. Another problem that we have over here is that we haven't applied these 5 rules. So what I'm going to do now, I'm going to transform this one by applying the 5 rules that I have shown you before. So let's apply the first rule. The first rule, if you remember, tells us that we need to show time comparisons on x-axis. And if you look here, we have time comparison on y-axis, which is not good. So let's rotate this one by 90%. And when we rotate it, we get something like this one. So now we have time comparison on x-axis, and this is the rule number 1. So we have 2021, 2022, 2023. All right, so we have solved the first issue. What other issues do we have over here before we move to rule number 2? We have so many colors, and colors are not the only problem here. The problem here is when you want to determine what does orange represent, your eye has to jump here from orange color to the legend that we have over here. So this is not good. We need somehow to link these two, and also we need to get rid of the orange color at all, because orange color doesn't tell anything. It just tells which category this belongs to. So what we can do is we can move these labels to the visualization and move them here. So it's much easier for you to read if you have the labels on the visualization itself. Another thing that we did here is we got rid of the unnecessary colors, and we can distinguish these different categories by using different shades of gray. So I've used black for this one, and I've used different shades of gray for another categories. So it's much easier to tell which category things belong to. Another thing that we did over here is, if you compare it to the previous one, we have ditched the y-axis, and also we have shown that all of these are at 100% maximum. So we have this line over here, which shows what is 100%. So we are not then confused if this ends at 100% or some other figure. All right, so what we're missing here, if you remember rule number 2, we are missing the title. So we don't know what do these figures relate to. Does it relate to just Serbian market, Europe market? Does it relate to the whole company, as in this example? So this relates to the whole company that we're looking at, and it shows the product mix in percentages from 2021 to 2023. So we are now sure what we're looking at. This is not just one store or just one market. All right, so let's see what we're missing now. So we're talking about 4% below plan, but we don't see 4% anywhere. Why? Because we cannot see the plan. So we don't have a plan in this visualization at all. We only have actual data. We only have data from the past. So we need to add the plan. Where am I going to add the plan? So let's see, when was the plan created? So if I'm looking at 2023 data, plan was created at the beginning of 2023 or somewhere over here. So let's add the plan over there. So let's add another scenario for comparison. And right now I can see the same data, but I can see 85% for women's apparel over here and 81% for actual. So now I see 85 minus 81 is actually 4%. This is what this person wanted to deliver as a message. So we needed to add this additional scenario, which wasn't in the visualization before. All right, so what is another rule that we have applied here? Distinguish scenarios by colors. If I added this scenario in the same colors as all the actual scenarios, you would think that this is actual as well, and you would probably think that this is 2022, not planned for 2023. So by distinguishing scenarios by color or by using outline for the planned data, I have managed to tell the difference between actual and planned data. And I'm not using any colors yet. I'm just using black and shades of gray. So what can I use the color for? I can use the color for highlighting. Let's give something here. So I wanted to show 4% below the plan, and I've used red color because 4% below the plan is something bad. I perceive it as a bad message. So that's why I added -4% over here. And this is the rule number 4. Variances are colored green for good and red for bad. All right, so I have highlighted this with red, and I can use blue highlighting to highlight it additionally because this is something that I have mentioned in the message on top. So this is something that I want to highlight additionally. So if we look at this one, this is the final product that we end up with. And if we compare it to the previous one, this one has much more power in delivering the main message that we want to deliver. And it's much easier for the other side to see the main message and to accept this message and to make decisions based on the message that is shown over here. All right, so if you Google the methodology that I have used over here, which is called success or IBCS, you can see that majority of reports look similar. And if you're interested in this topic, I suggest that you Google reports so that you get familiar with the notation used over here. You can see that mostly everything is black and white or gray. And the only colors that I used are green and red for bad and good, and blue for additional highlighting. Why is this? Why does this matter? Because if you want to look at two visualizations that were created by two different people, if they're delivering the same message, they should look the same. So things that mean the same should look the same as well, and that makes the communication much easier. So let's see, why does this work? I will mention a concept called System 1 and System 2 from the book Thinking Fast and Slow by Daniel Kahneman. And if any of you had the chance to read this book, then you know how these systems work. So what does it mean, System 1 and System 2? We have our System 1, which is responsible for making quick decisions. For instance, if you look at this line, your System 1 is going to tell you run. So if you are somewhere in the desert and you see the lion, you will run immediately. You will not have time to analyze the situation and to make a slow decision to walk away from this situation. You're just going to run immediately. The same thing happens when you look at any visualization. So when you look at any data, you want to make quick decisions or quick conclusions based on that data. So let's see an example of that. Let's look at this one. Sales revenue over the years. So if we want to analyze this message, it says GDF sales revenue was 4.3 million in 2019 and grew to 8.5 million in 2023. This represents a growth of 4.2 million or 98% over 5 years. This is not quick, this is not fast to analyze. And here you have to use your system you have to think a lot to process this message. It will be really hard to process this message, even though this is not complex data. We're not talking about neural networks here or some complex machine learning. We're just talking about basic sales revenue data. But if you want to leverage your System 1 you can create something like this. And this is the same data that we see in the message over there, but here we're leveraging our system one. So immediately we see the main message in this visualization. And this is why data visualization is important. And it's really important to know how to visualize things properly. All right, so let's look a bit at the history of data visualization. So the first data visualization dates to 18th century. William Playfair has published the first visual known and recorded. So here we can see the exports and imports to and from Denmark and Norway. And this is really good visualization because this shows when we're negative and when we're positive. And it's quite simple, but it delivers the main message. Then we can see some of the examples of the visualizations from the 20th century over here. And here we see visualization from Edward Tufte from the Second World War. So you can see that data visualization is not as recent as some other techniques that we are using, but still there are no strict rules yet, and people are just guessing what should they do. So if you Google dashboard, you will get something like this. This is what I got when I Googled dashboard. So you will get different dashboards, different colors, different types of graphs, visualizations, and this is not good. So we need to standardize things in a way in order to make it easier for people to perceive this. Where are we today? So we have lots of visualizations such as this one that I've shown you in an example. And the solution is that we need standards. So when we talk about standards, standards exist in many areas of life or science, etc. So if you look at this, we have standards in traffic. So this is from Saudi Arabia, and I think that even though maybe not anyone here speaks the language, but everyone here can understand the signs that you see over here. If you take the stop sign as an example, this is how the stop sign is used all over the world. So it looks similar. It always has the same shape. It always has the same colors, red and white. We have one little exception here, but it's so similar to another ones. And even though sometimes it doesn't say stop, as it does say here, sometimes it says in local language, you can understand this is a stop sign, or you can understand this hand, so this means stop. So how can we leverage something like this? Let's look at another example. This is example of a map. And this is a standard that we're not even aware of. Do you know which country this is? If you know, you can write in the chat, but the main problem with this one, if you haven't recognized the country, the main problem is that north on this map was shown in this direction. If you rotate it to the way that we are used to, so we are used to seeing north on top and south on bottom, then you get this map. And as majority of you come here from Serbia, this is the map of Serbia. So you know that this is Serbia just because you are so used to the standard that they use when they create maps, which says that north is on top and south is on bottom. And so this is a standard that we are not even aware of, but we are applying it. Same thing applies for architecture. So here we can see one architectural plan in a Slavic language. I'm not sure which one, but it doesn't really matter. We understand what they're showing. This is living room. This is kitchen. This is toilet. So it's really easy for us to understand this floor plan just because there are standards in architecture. Whereas with data visualizations, we have no standards. And what we end up with is something like this. So what I'm showing you here is I'm showing you one single company which has 3 different markets: Serbia, Croatia, and Bosnia. And a person from each market has created visualization for the same data for their market. So if you look at it, this person has opted for line chart. This one has opted for donut chart, and this one has opted for column chart. They're showing the same data. So shouldn't they look similar? And if we transform this one, if we start to think, all right, so if this is the same data, shouldn't it look the same? Let's apply some rules for standardization. We end up with something like this. So if you look at it now we can see that we are actually looking at the same data. This is Serbia, Croatia, Bosnia, and we can also see some other countries which weren't even shown in the first one. And we can see that it's the same data. It's divided by car, truck, and bus, by years, etc. Whereas here, it looks absolutely different. And here, it's so hard to compare things. If you want to compare car sales in Serbia to car sales in Croatia, it's so hard. So you have to look at 2023. All right, this is car, the green one. In Croatia, car is gray one, so it's this one. This is 2023, so it's 5 compared to 8. You have to think a lot, to waste a lot of time. Whereas here, it's much easier to do that. You see car here, car here. It's really easy to compare them, and they are on the same scale, so you can see which one is better than the other one. One of the issues with the previous one was that you had to waste a lot of time to analyze it. And another issue is that sometimes you can even trick another person if you add a 4th visualization like this one. Let's have a look at the 4th visualization. The 4th visualization was probably created by the same person as the 3rd visualization because they look so similar. So this is his style. But this 4th visualization is showing absolutely different things compared to the other one. So this one is showing 2023 by country and sales channel. So it's showing all of the countries and different sales channels. So this is absolutely different data compared to the other 3. And what we see here, visually, we would think that these 2 are somehow related. They're not related. So just because they are using the same styles, it doesn't mean that they are showing the same thing. And this is a really bad example. So you are tricking the other person visually, and the one who's analyzing this data will think that you want to show the same things over here, which is absolutely not true. So how can you avoid this message? Let's remember what we said. First of all, what's wrong with this one, apart from the coloring and stuff? We are not showing time series over here. We are showing structural comparisons. We are showing different countries. So that means that we should rotate this one and it should become horizontal. So let's see what it looks like now. If we add this one, so it's over here. First of all, you can immediately see that this is something else. So these 6 are related to each other. This one is something else. And you can see each country over here. They're all sorted in a descending order. And you can see easily direct and dealer. You can even compare these amongst each other. So it's much easier for the one who's analyzing this to get the right message. What is another thing that we can do now? Because we made our whole report grayscale, we don't have any colors anymore, even though we're showing many different categories and stuff. We don't have any colors. Once you get rid of the colors, you can actually see what's what matters, what is highlighted. If you look at this one example, so you have a picture over here, which is full of color. You cannot see the traffic light that well because it's just too much information over here. Isn't it better if you have the grayscale data and then highlight just what's important, which is traffic light in this example? So let's apply that to the report that I've shown you before. So if I want to highlight bus sales in Serbia, it's so easy now. I can just highlight this one with blue and I can see immediately what's happening with bus sales in Serbia. So I'm drawing attention to that. If I wanted to draw attention to something else, I would have highlighted something else. Is this one better? Or is this one better? Basically, what I wanted to show you with this is the way how to apply the success rules. So I'm going to repeat them once again. Success rules are rules or methodology that we use over here in order to create better visualization, in order to deliver better messages and to tell better stories with data. First thing that we used here is say it, deliver the message. So we were focused on the messages, and the messages were always the first thing that we were thinking about when we created any of these visualizations. After that, we applied unified standardization of notations, colors, etc. So I have shown you an example of how to use solid color for actual data, how to use outline color for planned data. Then we used condense, do not waste space. So use your whole screen. You can make the visualizations as small as possible, as small as visible, I would say. Then you can use the whole screen or the whole paper in order to tell the story that you want to tell. Check and ensure the quality of information. So you should always make sure that you're not tricking the other person into drawing conclusions that are not based on the data, that are based on some limitations of the tools that you're using or based on your personal styles and preferences and stuff. So you should omit all of that. You should always stick to the rules and stick to the way how the visualization is supposed to be presented. Express the message visually. So this means that you should always pick the right visualization which underpins the message that you want to deliver. So I've shown you an example. If it's time comparison, it's the best option to pick a column chart or line chart in some cases. And there are rules which relate to this as well. Simplify, make it as simple as possible, means that you should get rid of all the clutter, get rid of anything that doesn't deliver any message. So get rid of all the unnecessary colors, shapes, objects, etc. And finally, structure, organize the report in a way that is logical, that follows the message that you want to deliver. So that it's much easier for the other side, the other person who's looking at your report, to read the report and to understand your message. All right, so this was the whole success methodology that I have presented you. In the end, I would like also to present myself and my company that I come from. We are Management Center Beograd, based in Belgrade, Serbia, and we do consulting. One of our divisions is connected to data and business. So we do consulting and trainings in areas such as this one. So if anyone is interested, you can contact me directly, and we can have a chat and talk about this topic or other topics related to data science in general. And of course, you can meet me in person when the conference starts in Sava 10. All right, thank you all for attention. So if you have any additional questions or anything, we can use the time now. I see that we have some questions. Is it possible to share the PowerPoint, and can you share the link with materials? I will check this with the organizers, so the way how the materials are shared. So I'm sure that you will receive some sort of link with this as well. So if you have any additional questions, please feel free to ask them now, or feel free to approach me in person on Wednesday, Thursday, Friday. So thank you all for the attention.
Thank you, Milica. This is very interesting, and thank you everyone who watched the tutorial.